Hello, my name is Danny Crockett and I'm the CTO for SharkBite Tech. Today's discussion is the second of a three-part series that is designed to provide an overview of recent developments in WAN design. In particular, we're talking about how cloud services and technologies like 5G are changing the definition of the network edge. In the first part, we discussed the evolution of SD-WAN up to its current capabilities and identified a gap in securing network edges that are beyond the corporate network and firewalls. Solving that problem is today's topic. Next week, we're going to dig into SASE, what it really is, the problems it's designed to solve, and whether or not SASE finally provides the single comprehensive solution to a WAN that is secure, high performance, and economical for all edge use cases. Okay? So let's get started. So again, today's topic is addressing cloud security for remote users and unmanaged devices. So let's just do a quick review of what we discussed last week to get a level set for today's discussion. We arrived at the conclusion that to secure direct internet access at branch locations, many SD-WAN solutions require an additional on-prem next-generation firewall, or at a minimum, firewall as a service at each site. Also, that SD-WAN security measures can only encompass traffic that's traversing the corporate network. You have no control or visibility into direct access to cloud services when you're off network. From a remote access perspective, home running everybody to the corporate data center via VPN for remote work scenarios in order to secure their cloud access doesn't work well with legacy VPN architectures because they're based on appliances. You have capacity constraints, and their original design was more than likely built for short duration connections for a subset of your users rather than continuous remote access for all of your employees. So because it's built on a hardware-based appliance, it's not elastic in its ability to scale up or down. And sometimes even if the hardware were capable, you're limited by licensing based on the number of connections allowed at any given point in time. So that impacts the ability to provide security services for home users in the new work from home reality. Also, traditional inline firewall proxy technologies that are really focused on permitting or denying cloud resource access. They don't have granular control or visibility over the actions you can perform when you're inside of that application. So that lack of controls makes attaining regulatory compliance for cloud services difficult, if not impossible. So basically, we need to expand our definition of the network edge to encompass all physical locations, cloud resources, and mobile devices to both one another and the internet. So here's some of the questions we're going to try to answer with regards to regulatory compliance and visibility of data for BYOD and mobile. How do you maintain visibility of data that's not sitting behind your firewall or stored on managed endpoints? How do you manage the identity of the users who are accessing sensitive information? How do you differentiate the levels of access to sensitive data for managed versus unmanaged devices? And how do you do the same for sanctioned versus unsanctioned applications? And lastly, how do you provide zero-day threat protection across all devices, networks, and cloud applications? So the problem is that the cloud and mobile are beyond your firewall, and you can't protect what you can't see. So if your security architecture requires that the end users be behind a corporate appliance and or running an endpoint agent, those are increasingly not only unacceptable, but ineffective. For some companies, the move to public cloud application delivery and the need to secure unmanaged device access render traditional solutions ineffective. So our ultimate goal should be to provide data and threat protection for any app, from any device, from any network edge, without severely impacting usability or end user experience. And a key part that a number of companies lack in terms of cloud readiness is a SAML-based identity and access management framework. So robust authentication in the cloud in support of identity-driven network and security policy contributes to a lack of cloud readiness for a lot of companies. So to achieve these goals on unmanaged personal devices will require an agentless solution. And we'll discuss what the limitations of those are. And the hurdle is, how do we insert security monitoring and management into a SaaS application session that's off-premise and initiated by an unmanaged device? So let's go into a cloud access security broker and what it is. So CASB provides the following controls and capabilities. So at its heart, CASB is a cloud DLP solution. It's delivered primarily as a SaaS application, although there are on-prem components for different deployment scenarios. CASB addresses security gaps in an organization's use of cloud services, and it provides a consolidated view of an organization's overall cloud service consumption and footprint. And it gives you details about the users who access those services and the devices and locations they're accessing those services from. So it gives you a way to enforce data-centric security policies based on data classification, and it monitors user activity related to the access of sensitive data or privilege escalation. So policies are applied using controls such as audit, alert, block, quarantine, delete, and view only. Some CASBs even provide the ability on the fly to encrypt, tokenize, watermark, or redact content, both at the file and the field level. So CASB DLP features can operate natively, but note that they can also integrate with your enterprise DLP products, so via ICAP or REST API integration. And ideally, you want to be able to provide a degree of control that allows you to deny or control access to specific web applications in a SaaS suite. The example I'm given here is SharePoint or Yammer in Office 365, but it could be really anything. Applications like Salesforce have an entire spectrum of applications and capabilities, and you want to be able to have granular control over each of those. Secondly, threat protection. CASBs can prevent unwanted devices, users, even versions of applications and operating systems from accessing cloud services. Cloud application functionality can be restricted based on observations both during and after login. And that is critical. Again, traditional firewalls and proxy services tend to be focused on allow or deny. We need more than that. We need to observe what goes on both during and after the login. And the next point is that, as we observe user behavior, we use behavioral analytics against multiple sources of threat intel malware identification and remediation. We leverage these capabilities to really add another level of capability where we're really tracking user behavior, and that's important, as we observe, what are they downloading? Is it an unusual amount? Are there attempts at escalating your privileges? Are you making repeated attempts against things that you don't have rights to? These are important things to track. Now, a better CASB vendor is going to have their own analyst teams that are also researching cloud-specific and cloud-native attacks. You're going to want to talk to them about that. So, public threat intel is fantastic, but these are specifically cloud threats, and you want to know that your CASB vendor has a dedicated team researching cloud-specific issues. Compliance, in large part, that capability comes under the heading of CSPM, which is Cloud Security Posture Management, which continuously monitors the compliance of cloud user accounts. It's a core CASB capability. It's a core piece of any compliance posture for your company. We'll talk about it in a little bit more detail here in just a second. And visibility. All of these capabilities imply that you have visibility into all of these areas, which is great, but you really want to be able to leverage that visibility both from the standpoint of a forensic investigation as well as integrating that information and visibility with the rest of your security stack. So integration with your SIEM, integration with your on-prem DLP, and other parts of your existing security stack. It's critical to give them some of this visibility into what's going on in the cloud. So we've kind of answered some of these questions. How is CASB different from a web proxy or a firewall? Again, next-gen firewalls are focused on a wide variety of inbound threats and filtering on millions of potentially illicit websites. CASB has a pure focus on deep visibility and granular controls for cloud usage, and it has extensive capabilities for both data in motion and data at rest. And we're going to find out a little bit more about that when we discuss the 3 deployment modes for CASB. So some of the capabilities that we're talking about include cloud service risk assessment. A CASB can provide a detailed, independent risk assessment for each cloud service. It might include things like a report on compliance certifications, any recent data breaches, available security controls that you may or may not be implementing, and even the legal jurisdiction that cloud service operates within, which can be very important. Out-of-band capabilities, this will relate to what is known as an API mode deployment, but we mentioned that a CASB can operate on both data in motion and data at rest. The data at rest capabilities arise from the ability to integrate with the cloud service providers' native API to be able to scan and operate on data at rest. And we'll discuss some of those capabilities. Other out-of-band capabilities relate to some of the integrations with other parts of your security stack, the ability to ingest logs and packets to gain insights into shadow IT activities, for example. The out-of-band capabilities can really add a lot to what the CASB can do in addition to what it can do in an inline capacity. Risk-based policy enforcement, we're talking about actions such as blocking access to all high-risk file sharing services, and perhaps even popping up and displaying a real-time coaching message directing users to a company-approved service. Controlling individual user actions based on context, again, that is also at the heart and soul of what a CASB is supposed to do. So might include preventing users from obviously downloading sensitive or privileged information to and differentiating between unmanaged devices, or perhaps it will limit you based on whether you are on the corporate network or on a remote network. And the usual range of DLP style actions, allow, block, we can encrypt. A lot of CASBs have the ability to encrypt on the fly. They might zip the file and apply a unique user-specific password for that file. We can wrap the data with digital rights management. We might require for particular grades of information additional authentication before you're allowed to view the files. And you might be permitted to access the files offline, but only for a preset period of time. And as we mentioned before, we also have masking capabilities. So that depends on the cloud service utilizing Microsoft's Active Sync protocol, which we'll talk a little bit more about in just a minute. But if it supports Active Sync, you can redact or delete text based on keywords, regex. Gives you a lot of power as to what you allow your users to see and within which context. Again, you've got authentication, you've got location, and you've got what type of device you're using, and those all figure into the equation. Cloud Security Posture Management, CSPM, we mentioned that on a previous slide. CSPM is the continuous compliance checking of cloud platform accounts. So for example, it allows a CASB to crawl infrastructure as a service instances like AWS, Azure, Google Cloud, in search of inconsistencies with either your own custom benchmark or established standards such as CIS benchmark, HIPAA, PCI DSS. A good implementation allows you to enforce consistent policies across all of your cloud service providers. It can also notify the end user and administrators of a misconfiguration, describe what those misconfigurations are and what their impact is, as well as how to fix them. So as more and more companies move their data to the cloud, CSPM is becoming a mandatory aspect of security. Data-centric security policy enforcement, again, along the lines of capabilities we've talked about before, forcing actions such as encrypting the data as it's uploaded to the cloud, for example, or applying rights management to sensitive data on download. The policies are applied through controls that you dictate, and some CASBs even, apply encryption, tokenization, watermarking. So these CASB DLP features, again, can operate natively or in conjunction with policies you've already defined in your enterprise DLP product. If we can't respond to threats in real time, then that response is very limited in its usefulness. So, for example, you want a user account to be disabled immediately if you just detect an insider threat. Or at a minimum, if you think you've detected a threat, you want to pop up and maybe give them an additional factor of authentication. So, this is critical, and not all of the modes of operation for CASB are real-time. We'll talk about that. Advanced threat detection methods. This gets into essentially providing endpoint security features, even on unmanaged devices. So we can use, for example, machine learning to look for cross-application user behavior and analyzing that. As an example, it could be used to detect something like an unusual volume of sensitive data being uploaded to a personal account and unsanctioned cloud application. So typically, quite often, CASB vendors have a technology partnership with an endpoint security partner, and that's where these advanced endpoint security capabilities and zero-day protections are coming from. Finding out who that is, if that's the case, that's certainly a part of your RFP process. So taken together, when controls like these are implemented, SaaS and infrastructure as a service capabilities can be made even more secure than traditional premises-based infrastructure and tools. So let's just take a minute to talk about sanctioned versus unsanctioned cloud application considerations. So addressing data leakage from sanctioned apps to unsanctioned apps is absolutely critical. This activity is normally invisible for unmanaged devices on public networks. CASBs are designed to address that fact. Robust authentication, we've discussed that before. We have to have robust authentication in the cloud to lock down user accounts to cloud resources. Now, the CASB, if you don't already have that in place, some CASBs have a dedicated identification as a service capability that can certainly, at a minimum, help you in the short term. So, in order to secure both sanctioned and unsanctioned apps, a CASB that supports multiple modes of operation is required. So you will hear next-gen firewall companies talk about their CASB capabilities. It is almost exclusively limited to API mode capabilities, which is not inconsequential. It's just insufficient. So we'll talk about that in a bit. In order to secure sanctioned apps on unmanaged devices, the CASB has to implement what is known as reverse proxy mode. And that has to be implemented in the cloud, preferably using a cloud scale architecture. If you want to secure unsanctioned apps, and if you want to do shadow IT discovery on mobile devices, that will require the use of a forward proxy CASB. So a BYOD security program is critical, yet a lot of times it's not addressed. Many employees refuse to use agents on their devices, typically deployed using a mobile device manager or MDM. An agentless way to secure corporate data on devices without encroaching on employee privacy is needed. Now, I want to note, we talked about active sync just a few moments ago. A CASB can actually encompass many MDM capabilities if it implements an ActiveSync proxy, either in the cloud or in an on-prem forward proxy capacity. So ActiveSync is an XML-based Microsoft synchronization protocol. It is supported on every mobile device pretty much on the planet. Runs over secure HTTP, Office 365, Google Suite, Slack, Salesforce. Many cloud apps use it. And ActiveSync gives you capabilities such as I can send a remote device wipe command that can selectively wipe just the data from that ActiveSync enabled cloud application, should that device be lost or the employee be terminated. In that way, it preserves your private information. It only wipes the ActiveSync application's data. So a CASB that implements an ActiveSync proxy can enforce. It can also enforce data security policies like password strength levels, your PIN parameters, and it can make sure that on that particular device, all data is encrypted, for example. So we mentioned the 3 modes of CASB operation and their use cases. So let's go into a little bit more depth. We mentioned API mode. It's an out-of-band deployment mode. It's very useful for scanning data at rest in the provider's cloud. It's completely transparent to the end users, but here's the thing. The APIs exhibit latencies of a few seconds to a few minutes. So API mode is not a real-time enforcement capability. However, it is the only mode that allows you to operate on the data sets that are actually in the cloud. So, if you want to retroactively encrypt data that's in the cloud, API mode is how you're going to accomplish that. So, as I also mentioned earlier, other out-of-band deployment modes aren't often discussed, but a CASB can ingest logs, and it can also ingest packets. Now, how you get those feeds and integrate into your current security capabilities, that's something you need to spend a little bit of time working on before you deploy your CASB. But the CASB can reconcile those against its own threat feeds to look at traffic from a cloud security perspective to identify high-risk traffic and activities. It also gives the CASB the ability, out of band, to report on shadow IT. Particularly as it pertains to things like Dropbox, where a lot of people have personal Dropbox accounts. Forward proxy is a first mile technology. It's typically implemented, it can be implemented both on-prem or in the cloud. Since it acts as an SSL man in the middle, we have to use a variety of mechanisms to try to steer traffic to the proxy. So that can be deploying an agent on the mobile device or desktop. If we want to avoid deploying yet another agent, we can do on-prem. We can do proxy service chaining the same way that we introduce other inline capabilities. That complicates things typically from a routing perspective, trying to get that traffic to go through all of these inline devices. We can also use a DNS redirect or a browser pack file. But the bottom line is, if you're deploying forward proxy mode, you're deploying to a managed device. So the unmanaged BYOD use case would remain completely unsecured with forward proxy mode. It doesn't address a mobile device on a public network accessing your apps. So now we get to reverse proxy mode, which is designed to secure sanctioned app access on any device. So forward proxy mode diverts all cloud destined traffic through the proxy. So forward proxy mode can be used to detect shadow IT. Reverse proxy mode only steers sanctioned application traffic through the proxy. So the reverse proxy, it's implemented in the cloud. It's more of a last mile technology because it sits in front of the cloud service to provide inline capabilities. We're going to go through the communications flow and the authentications flow for reverse proxy in the next slide, but it is wholly dependent on seamless integration with a SAML 2.0 compliant ID as a service provider. So that is critical. So customers can use a reverse proxy to add inline capabilities for users that are off-net on unmanaged devices. But note, again, you cannot detect shadow IT in reverse proxy mode. And the last thing I'll say on this slide is that almost all CASB implementations are what are called multi-mode. If you're only going to use one mode, it's probably going to be API mode, but we almost always leverage at least 2 and often 3 different modes of operation to secure all possible use cases. So let's talk about how do we get in line in the reverse proxy mode with people who are off-prem on an unmanaged device. So it starts off, the user just connects to the cloud app as they normally do. That cloud application was configured by your company's administrator for that app to redirect to the cloud CASB provider. The CASB provider is similarly configured to redirect the browser session to the identity provider. Now, it's possible that you're using the CASB itself to provide those ID services, in which case you could skip 2B. But essentially, again, SAML 2.0 cloud-based authentication is critical. So once you're authenticated, the user is then, and again, this is all driven by browser redirection, the user is redirected back to the cloud CASB provider, which is now in line with the session and acting as a reverse proxy. So from the user's perspective, nothing changes. There's no need to retrain them, no agents to deploy. The user experience for reverse proxy mode is the best. Now the session, because it's a proxy, the session that's established between the client and the CASB is separate from the one that is between the CASB and the cloud service. So if the user tries to open a new browser window and connect directly to, for example, Salesforce, it's treated as a completely new session. So they get pushed back through the same process again. Therefore, the app is always going to end up being secured by the CASB no matter what. So one caveat that you will have to test is that this works for browser-based app instances, but it may not work for a thick client, for a desktop app. If you're deploying, the full version of Microsoft Office and Outlook on your desktop, those use cases may require the use of an agent and a forward proxy. You'll have to talk to your CASB vendor to see whether or not that's true. So as you're looking at different CASB providers, let's talk a little bit about their infrastructure and considerations for that. So clearly, since it is a cloud-based SaaS type of service in most instances, you want a solution that's built on cloud scale technologies so that it'll scale both up and down elastically, and avoid any performance issues related to proxy mode scanning. SSL man-in-the-middle type proxy scanning is very resource intensive. So if the service is built on essentially a virtual machine version of a hardware appliance rather than containers and other cloud scale technologies, then its ability to scale for you is going to be limited. So you want to dig into the details about how they implement their service. And you would also want to get some information about their cloud service uptime, both from a historical perspective and what they currently commit to in an SLA. You want to take a look at their POPs. Again, you want to see if they are self-hosted or, ideally, if they're based on a robust infrastructure as a service provider like AWS, Azure, as well as the number and geographic distribution of the POPs. Ideally, they have a global footprint, but if not, you want to make sure that their geographic coverage mirrors your company's profile. And if you don't already employ an external single sign-on provider, make sure that your potential candidates can provide that service themselves. At least in the short term, that's going to be a necessity. We mentioned this before. For the zero-day threat, email, malware, basically endpoint protection capabilities, you want to find out if those are native and developed by the CASB provider themselves, or whether they partner with another technology provider. And then you're going to want to take a close look at that provider's capabilities. It's critical to know how large their index of cloud applications is, and whether they curate that list themselves, and how that list is updated, how it grows, and the same thing for their sorts of threat intel. Do they curate it? Do they contribute to it at least? And do they have their own research teams behind it? And then lastly, how do they deal with dynamic content that's executed in the browser? Because so much of the web now, the content is active. It's code that's being executed locally inside the browser that's not visible necessarily to an inline proxy. So how do they deal with that? Now, the ideal answer is that within their proxy, they also virtualize the browser session, execute that code, and by doing that within the virtual browser, they can use the end result to direct the end user's browser to the correct URL. But you really want to have a good conversation with the CASB provider is how do they deal with dynamic content. So let's start to wrap up here. Can SD-WAN, and I have to modify this because it's not just SD-WAN, it's really any corporate network. It doesn't have to be based on SD-WAN. But by adding CASB, can we provide secure access for all network edges? And the short answer is yes. For our discussion today, because it followed a discussion of SD-WAN, we focused a little bit on CASB as a way to supplement SD-WAN to provide secure public network access for sanctioned corporate apps on any mobile device on any network. From that perspective, CASB does in fact address use cases that are beyond the corporate firewall or other technologies like proxies. secure web gateways, so on and so forth. You will hear an argument, or you may make the argument, that my company forcibly restricts remote access to sanctioned cloud apps by only allowing managed devices with endpoint agents. Does that protect sensitive cloud data? I would say no. So first of all, if you're not protecting cloud data downloaded or synchronized to mobile devices, you're not really protecting your assets in the cloud at all. And from that perspective, I think an MDM gives you a false sense of security. A CASB has much more granular control of the flow of data to the device, using DLP and a range of remediation actions. That goes well beyond an MDM's ability to mitigate risk. Again, the combination of MDM and the agent and how you configure the cloud application acts more as a gatekeeper, but it doesn't give you visibility or control into user behavior and operations on data in the cloud after you're let in. Also, cloud applications rely primarily on third-party apps from an app store or the apps that are built into your mobile device, to access things like mail, calendars. That essentially renders the app wrapping methods that the MDM vendors depend on mostly useless. So finally, a CASB doesn't have the deployment and privacy challenges that are associated with managing BYOD devices. When you use an MDM on a non-corporate owned device, it's a force fit for BYOD, and the users generally hate it. So much better to go with something that's frictionless that your end users will embrace rather than try to work around. So let's reframe our discussion of CASB, because up to this point I've been discussing it from too narrow of a point of view. It's much more than just a point solution to secure remote cloud app usage. It should be a core component of any company's cloud security strategy and posture. Even internal users behind the firewall or other proxy should be going through a CASB. And in particular, if it's implemented as a reverse proxy, it extends granular DLP capabilities to every sanctioned cloud application usage scenario. And remember, a CASB is most powerful when it's implemented as a combination of the three modes, and that combination needs to be optimized for your particular enterprise and users. So before I wrap up, just a couple more recommendations. Remember that in particular, API and reverse proxy modes are very easy to deploy without modifying your infrastructure. They lend themselves very well to a proof of concept. So keep that in mind when you're figuring out how you're going to test these things. You really want to dig deep and examine exactly how you want to integrate the CASB with your existing security stack. This, in addition to making your CASB deployment more effective, will make your entire security stack and investigative capabilities much more powerful and extend them greatly as it pertains to activity within your public cloud profile. Phase in your CASB deployment. I would initially put it in monitor mode, establish a baseline, perhaps, depending on the mode, do some shadow IT discovery. Perhaps you'll discover some actually sanctioned apps that you weren't aware of. So, use monitor mode to establish a baseline and do some risk assessment and prioritization. And then lastly, as always, measure your success. How many cloud services are you actively monitoring and managing? How many unsanctioned applications did you discover or block? Are your end users happy with it? Are they adopting it? Are they satisfied? How many risky behaviors did you block? How many DLP type incidents are you able to coach your end users through? How many of them are self-remediated by the end users? How many compromised accounts or insider threats are identified, and how long did it take to detect and respond to them? So just food for thought. So I want to thank you for your time today. I've tried to keep our discussion of CASB technology vendor neutral and just provide some concrete examples of concepts and criteria that you should consider. So next week for our final webinar, we're going to dive into what SASE is, what are the problems that it solves, and what it brings to the table in terms of overall discussions for all network edge use cases. So thank you again for your time, and have a wonderful day. That's the one. Oh!